Welcome to ASTI Feynman Challenge 2025.
Good day and salam sajatra to the respected judges, teachers and fellow friends. Today my group Science Legends are going to present a very interesting project. Before that, let me present to you guys my group members. Scientist
Viraj.
Scientist
Hezekiah.
Scientist
Hussain.
Scientist
Sherman.
For myself, Scientist Pugalendi. I'm excited to share something that could change the future of farming. Our very own smart farming robot. Now I'll pass it to my colleague, Scientist Sherman.
Farming is the backbone of our country, but sadly, many farmers still face big challenges like a lack of manpower, this changing weather and water shortages. At the same time, technology is growing fast, so we ask ourselves a simple question: how can we use technology to support our farmers? Now I'm passing it on to my scientist Viraj.
Before we get any more deeper into this project, I would like to share two basic fundamental facts about our project. Number one, our project uses a venturi nozzle initiated by this pump. The average speed that we have
You can see the water in Cecil.
recorded of the water shooting out is 5 kilometers per hour. Number two, our project uses a relay, two relays actually, a transistor and our Arduino and sensor and potentiometer inside here to control the system.
Okay. When the Arduino turns on, it sends a trigger to the sensor which starts the detection. The detection will be over a 10 centimeter range. When something is detected, it will turn on this green LED. First, the green LED will turn on. Then, to indicate that it stopped, the yellow LED will turn on. And if more than 2 times it is stopped, the white color LED will turn on, indicating it's locked. While the orange LED is turned on, this pump will turn on and pump water up from here to here.
Now I'm passing it over to my colleague friend, scientist Tushar.
The aim of our project is to create a robot that can help farmers to manage their work more easily, save water and improve the way they grow crops. And now I'm going to pass to my scientist Ezekiel.
We designed and built a smart farming robot. This robot can move on its own, detect when the soil is dry, and this robot can even water the plants. It uses an ultrasonic sensor. The robot avoids obstacles, waters only when needed, and runs on low energy. Not only that, there's even more. It is programmed using Emerald, which is made for farmers that they can use it more easily to build a smart farming robot that functions with simple coding blocks. What makes this robot special is not just for its features, but its purpose. It can help farmers save time and reduce hard labor, and protect the environment from avoiding water wastage. It is also small and affordable, making it perfect for small-scale farmers or home gardens during testing. So, why is using this robot important? So that we can avoid obstacles just like a real helper on the farm. Now, I would like to pass it off to my friend Viraj.
Now I'm going to explain to you how this robot works. So we're going to use many things such as a screwdriver, 3 batteries, a relay as I mentioned just now, pump and also a hobby gear motor. First we're going to have a look underneath. The robot uses 2 dual H-gate relay systems, or the model is LA29N. It is connected via the 4 out pins, 4 in pins and both the EN and EB pins. First, we're going to zoom in on this motor as an example. First, it's connected to the out pin 1 and 2. Then that is relayed from in pin 1 and 2 to the Arduino at pin 5 and 6. This motor is enabled by the EN pin 8. We jumper it manually instead of using jumper caps to 5 volts. Now let's go back up. This robot controls this pump by using a transistor. The transistor's model is KH2004. Now let's see it in action, shall we? First, what you have to do is connect the pump's terminal to these crocodile cables. Next, what you have to do is power the Arduino. If the pump is working, it will create a brrr sound. So, let's do it. My scientist colleagues Pugalanti and Hezekiah are going to help me. You also shouldn't forget to power the pump in a separate line. So let's see it in action. As you can see, you probably can't hear, but as you can see, the pump is actually pumping out air. Now, as a special feature, because sometimes the car stalls, every 2 detections, this white color LED turns on, indicating that the system has been locked. Now, in case that fails, which has happened quite a few times, we've engineered and innovated a sparkless manual release. You find this particular purple wire and you just pull it. Now, no matter what you try, the Arduino is locked. No matter how much power you put in it, the Arduino is locked. Now, I'll pass it on to my dear colleague friend Tushan to explain the rest.
Let's imagine a future where every farmer gets the help they need, where food grows faster and safer, and where science and nature work together. That future starts today. And now I'm going to pass to my scientist, Pugalanti.
Thank you, and may our small robot help grow a better and smarter world for all of us. Thank you.
Thank you.
Bye-bye.
Bye-bye.